So guys, now we will try to understand this diagram for us. This is the piping diagram for the stunt tube air seal type system. Okay, let us see what all things are there and how the air and oil lines are passing. So air is supplied from here. Air is supplied at 7 bar pressure. So here is the pressure regulator. So pressure at this point here becomes 3 to 4 bar, because that is the pressure you are requiring, not 7 bar. Why? Because the pressure should not exceed to a very high level. You see, the head here has been shown. This is the shaft water line and this is the pressure head. That is the water level.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Okay, loaded water level, maximum water level. This is the ballast water level. So how much is the pressure? You can see from the shaft center line, it is maximum 9.26 meter. So 9.26 meter corresponds to 0.92 bar, that is approximately 1 bar. So if your maximum seaside pressure is 1 bar, how much do you want the pressure for the water for the air to be spouted? That should be around 1.1, not too much, because if it is too much then your seals will have additional pressure from the air side. So air is which is coming into number 2 and 3 should be approximately little bit higher. Why? Because the air which is given between number 2 and 3 will have to overcome the pressure of number 2 sealing ring, which is pressing against the chrome liner. So number 2 sealing ring will have a pressure drop over here. So at number 2 and 3 your pressure should be a little bit more higher than that pressure. So if we see one chart over here, this is the pressure ceiling chart. If your seaside pressure, this is the seawater pressure. Outside you have seawater. Okay, between number 1 and number 2 you have air. Number 2 and number 3 you have air. Number 3 and number 3s you have oil, and then you have stern tube bearing lubrication oil. Okay, this is the stern tube pressure. Okay, so how much is the seawater pressure? That is depending on the draft condition. So maximum draft here, if you can see in the diagram, can be 1 meter and can be 0.414, that is 0.4 bar approximately. So that is the pressure reducing approximately between 0.9 to 0.4, that is 0.5 bar pressure from the seaside can reduce. Every 1 meter corresponds to 0.1 bar pressure increase or reduce. Okay, so that much only it can vary. Okay, so I also need my air to flow from this side to be that much only, that can be higher than this pressure, not too much. That is why I don't give 7 bar air, I give only 3 to 4 bar, and then I pass it through a flow meter to know the actual amount of flow. And the main concept is this is a constant air flow type system. Flow is the main agenda here. 40 to 50 liters is the normal flow rate per minute of air. Okay, can be varied. It can be as minimum as 10 liters also can be. So it is managed at 40 to 50 liters per minute, and depending on this the pressure will vary. The pressure will change. because of the C condition over here. We will see about that how the regulator regulates it, but the flow controller here is the one which is regulating this flow. Okay, now we understand that the pressure should be, what should be the pressure scenario. As you can see, the C side pressure is the minimum pressure. Then comes the pressure at number 1 and number 2 seal. Since we are giving air directly into this chamber between 2 and 3, this is the pressure that we are going to expect here. Seawater side pressure, that is depending on the draft, plus how much pressure you are giving it. You are giving it 0.2 to 0.4 bar above the seawater pressure. You want only 0.1 bar extra. So as you are giving 0.2 bar extra over here, the pressure drop is expected to be 0.1 bar at this junction. So at point number at this position, seal 1 by 2, you will be getting seawater pressure plus 0.1 bar, seawater pressure plus 0.1 bar, which is just enough to press up this seal, press this seal up and go out into the sea. So just enough, not so. One more advantage, I will show you a study. One more advantage of this air seal is that the seal ring's life is extended for a longer period of time, because in the oil seal conventional system, it was the seals were exerted at very high pressure. Okay, so the tightness was also more, and the oil pressure was very high, due to which the seals were any vibration or leakage was not able to be compensated, and the seals were leaking because the shaft is also tending to vibration. Air acts as a buffer here, so that is the second advantage. Any shaft vibration, any undue vibration or change in the system, say movement, axial movement, is also compensated by this air. Okay, third, the air system has the pressure is not so much, plus the air is spouted out. The environmental effect we are all aware of. So air always can go out, or seawater can very rarely not come in, and oil can also not go out, because air is acting as a buffer here. Okay, so air is not directly, so oil is directly not in contact with the seawater, like in earlier models, oil models, where oil was directly in contact of seawater. One seal leakage and oil is going out into the sea. Here it is not like that. Air is like a barrier between the two. Okay, so this is the second chamber. The pressure is 0.2 bar above this. Now comes the oil side. This is the third 3 and 3s seal number. So in this section, we can see that between 3 and 3s, the oil pressure which is coming from your oil tank, okay, which is coming from the stern tube loop oil tank, should not be very high. That is, it is saying that the pressure should be equivalent to, almost equal to 0.5 bar. So the oil side pressure should almost be equal to 0.5 bar higher than this. Why we have kept it higher? So that the air is not allowed to leak out into this. Otherwise, air will keep going in this side if the pressure is less. So deliberately the pressure has been kept higher here, and the same pressure, because that is coming from the same tank. The supply to the oil supply to both the chambers are same from the same tank. So the pressure difference is 0 over here. Both the units are having same pressure. The 3S unit, 3 by 3S, and the bearing section, the section which is just beside this, this section, this section, the bearing part, that is also having the same amount of pressure. So the difference is only 0.5 bar. If the difference increases by this, we need to adjust by a regulating valve given in the system. Okay. Now let me come to the system explanation. Okay, so we have understood what is the pressure differences. Now if you see by the filters your air passes, there is a pressure drop, cannot be more than 1 bar. There is a pressure regulator over here, R1. You can see it is the pressure regulator which is reducing your pressure from 7 bar to 3 bar. Then there is a flow controller which is maintaining the flow to 40 liters per minute, 40 to 50 liters per minute. Then there is this non-return check valve. So there are two flow controls. One is in use at one time. There is a changeover switch over here. This changeover switch, when we press, it will change over from one side to other side. Only difference is that the first one has got a flow meter, the second one does not have a flow meter. You have both the same regulators over here. So pressure line will reduce to 3 bar through this system also. In case this one is not working, your second system will be manually, it has to be changed over. Okay, there is a changeover mechanism over here. So air will pass from this mechanism and this mechanism will be blocked. So there is a 2 by 3 way valve over here. Okay, this is like a non-return check valve. The ball will be pressed in the other direction and air will pass like this. Otherwise the ball is kept pressed in this direction. Okay, and the air is passing from this way. Okay, here you can see this is connected to a section where you have a pressure transmitter. So this is your pressure switch or pressure transmitter, which will give you a low level alarm, low pressure alarm. Okay, and you can test also. This is a plug for testing this. You can reduce the pressure over here and check the alarms also. So there is this important alarm which gives you alarm for low pressure in the system. When the pressure goes below 3 bar, the according to the flow, then the pressure is amount of air is flowing according to that, because 3 bar is the pressure maintained here, but according to the flow of air, the pressure is then sent into the system. Okay, as you can see here, this will be the low alarm, low pressure alarm, and this is the pressure given at the P4 junction. So whatever pressure is passing through the flow controller, that is the pressure over here, shown over here. That is depending on the draft condition, and that pressure is dependent on the draft condition should be always higher than this pressure. So how much it should be higher? 0.2 bar or 0.4 bar at this section. So 0.4 bar, if you will see the maximum draft, so this pressure will be 1 plus, so 1.1 will be this section and this will be 1.4 bar by the draft. If you can go, the maximum pressure over here can be 1.4, 1.5 bar. Okay, 1.4, 1.5 bar. The setting of the alarm will always be below this pressure setting, so that you will get a low pressure alarm at this junction. Then there is a V4 valve, normal air valve. Okay, this line here is important, which is connected by V8. It is connected to your stern tube lube oil tank to pressurize the stern tube lube oil tank at the same pressure as your air is flowing. So whatever is the air pressure in this line, same pressure is acting on top of the gravity tank. Okay, on the top of the stern tube lube oil tank. Okay, not the gravity tank, stern tube lube oil tank. Okay, now there are 3 alarms connected to the given to the control room. One alarm is this low pressure alarm, low air pressure alarm here. Second alarm is this alarm which is coming from the stern tube lube oil tank. This tank. This is your high level alarm of this tank. Okay, high level and low level. So this tank has got 2 alarms, high level and low level, 2 alarms here, and 1 alarm is for the drain collection tank here. From this section, this you can see it is going down into the drain collection tank. So you have got a high level alarm over here, high alarm. Okay, so this has got both high and low alarm, as you can see it over here. So from this section, there is a 3-way valve here. The reason for 3-way valve is whenever say your system has got problem or the airflow is not coming. It can be a chance that it has happened due to moisture, dirt, dust, etc. have been stuck in this line. This line is choked or something like that. You can change your first thing when you get a low pressure alarm, you check the air pressure. If the air pressure given in the system is sufficient, there is the filters are clean, what you can do is you can change over the line to the freshwater side and give, instead of air, give fresh water, so that anything which is blocking the system can be cleared out and spouted into the sea. This is fresh water, no problem. It can also be going out into the sea. So environment friendly fresh water can be given into the system. So that is why three-way valve is given to allow for fresh water whenever there is a problem with the, say, air system, to check whether you can clean the system and again reuse the system again. Okay, now coming from here, the the air is going into the chamber with V37. Okay, from here valve 37, and from the valve 37 you can see the dotted line, and it is transferred to point number 2, seal number 2 and 3, and from this the air is going in, and and from this side the 2/3 line is connected into, because the air is moving out into the sea. Okay, so there is no returning. The 2/3 line, another line is connected here to the drain collection tank over here. Okay, so this is the valve for the drain collection tank. So if any seawater will leak, will directly come into this tank. If any oil which is coming from, say, number 3, if number 2 seal is leaking, seawater is come directly to the drain collection tank. If number 3 seal is leaking, oil will directly come into the drain collection tank. Okay, now come to the, so this is the air line. Okay, now come to the oil line. Okay, so you can see this is the oil tank. Okay, so this is the stern tube lube oil tank unit. It has got a safety valve, so that because this is a pressure unit, there can be chances that over pressurization can take place. There is a safety valve provided to release the excess pressure, to remove the excess pressure if the tank is pressurized. Okay, there is a vent over here. This is normally closed position. This vent is closed. We have discussed about it. There is a drain. This is also normally closed to check the contents. If any seal is leaking, there also that, and empty the contents if you have to change the oil. That's why a drain is provided. The oil goes out. So this is the inlet to the sealing system. Air from oil is going inside the system through this. The important point is, you can see that tank is at a height of 2 to 2.5 meter from the shaft center. So every 1 meter height is 0.1. So if your tank is at 2 meters height, it is 0.2 bar pressure increase due to this head. So 0.2 bar plus the air pressure. So that is why your 3/3S cell will 3/3S sealing system part will always have excess of 0.2 bar pressure than the other system. Plus there is a oil pump in circulation, where you don't have a pump over here. You have a pump for circulating, due to which there will be a pressure further increase. But they say that it should not be more than difference between 3 and 3S and 2/3. These two chamber, the difference in pressure should not be more than 0.5. Why? Otherwise the seal will be pressurized more. Number 3 seal will be pressurized more. So from this section, the oil is going into the chamber. Okay, these are the filters in the line. Through the filter, there is a pump, and from the pump it is going into the system. So since this is an hydraulic system, in every hydraulic system you will find an accumulator. So you have got an accumulator. These symbols are shown for air. All the accumulators are having some nitrogen or air pressure from the top. So basically this must be nitrogen to balance out the pressure. So to avoid such pressure fluctuations, there is an accumulator in the line. Accumulator. Okay, So this is passing through these two. If there is a problem with accumulator, you can change over, bypass the line and change over from this section and go like this. There is a very important part in this section is the V27. This is a needle valve. The purpose of this needle valve is, say your pressure has increased due to say pumping action or something else like that, the pressure has increased by more than 0.5 bar. So in that case, by opening this needle valve, you can bypass the oil little bit so that the pressure is reduced in the pumping system and the pressure is now regulated to less than 0.5 bar between the two sections. So by this regulating valve or the needle valve V27, you regulate the pressure in the system. Okay, pressure in the oil pressure system. From here it is going into this section. Okay, and this is the entry of your stern tube. So stern tube oil is entering into two chambers here. One is this chamber, because this is a big section, so they have transmitted the oil into two sections. It is entering, making an entry here also and here also, center also. Okay, so this is the entry of the stern tube oil into the system between the seals, and there it has also to go between the 3 and 3s seal. So it is also coming from here, this line V31, you can see here. From V31 the oil is entering into the sealing system. So this is connected through small pipes. It is going into 3/3s. Okay, 3/3s oil in, as it is written over here. Oil is entering inside from here. This is the oil outlet, 3/3s oil out, going out from this V38 valve, and from this also the oil is outlet of the same chamber. Okay, important point here, one thing to be noted is, here is they have provided a vent in the line over here. This is generally, okay, this is generally air, this is an air purging line. So when you are starting the system, before starting you keep this open so that air is purged out when you are filling oil in the system. Otherwise you keep it closed, because you need to keep the system closed, right, pressurized. So that is why it should be closed, otherwise the oil will have a tendency to leak out. But initially, because when you are filling the system with oil, the air needs to be pumped out, purged out, otherwise air will not allow the oil to be going in. Okay, from there the oil is rising over here and then it is returning back into the tank. Here you have got a P12 pressure, P12, that is the return line pressure that you can see over here. That is the pressure of the oil chamber. So this is the oil chamber, its pressure you can come to know over here. Okay, the differences in pressure you can come to know from P4 and P12. So if there is a difference of more than 0.5 bar between P4 and P12, okay, P12 minus P4, if is greater than 0.5, you need to adjust with the valve number V27. So this is about the stern tube oil tank. Now come to the forward seal tank. Okay, so you have here, this is the forward seal tank. Okay, drain tank we have already talked about. The drain is coming from 2/3 number seal. It is also having one pressure gauge which is showing the pressure, how much is the pressure in the drain line. Okay, so 2/3 line pressure can also be seen over here, P10. So instead we can say that you can reduce P12 minus P10. If the pressure gauge in the drain collection unit is showing whatever pressure is the pressure of the 2/3 3 line, right? Because this drain line is also connected to the air line. So whatever the line pressure is there is the actual pressure of the air line, right? Either P4 or P10 will be at the same pressure. Okay, I hope you understood. It is at the same pressure, P10 also. Okay, so you can reduce this also. P12 minus P10 should be greater than, should be less than equal to 0.5. So not more than 0.5. Should be less than equal to 0.5. This is the flow control. We have already talked about flow controller. Because the air is coming from here, air has to be vented out. Air has to be vented out. Air is spouting out into the sea, and some air will be always draining out from this section. So this is also to control the flow 5 liters per minute. And during inspection, you have to check that this vent is clogged or not. Always daily rounds we have to check. If this vent is clogged, any seawater leakage from this sealing system will not be allowed, because this will become a pressure chamber, will not be allowed in the drain collection tank. Now talking about the forward seal tank over here. So this is the forward sealing unit, forward seal pressure unit. You can see there are 2 pumps over here. It is taking suction from, there can be a small forward seal tank also. In this diagram they have shown it by a sump tank. There can be a small forward seal tank over here also, located at some height to increase the pressure, or you can use a pumping system also. So you can take a forward seal tank placed at a height, or you can use a sump over here, sump tank. No need of another separate tank for the forward seal, only you need to have a forward seal pumping system. So in this one they have done the same. So this W1 here, W1 and W2 is connected to the sump tank, taking oil from the sump this way, giving it between 4 and 5, and taking oil out from the sump. There is a sight glass to check whether any other thing is coming in. I mean any ingress or dirt or something like that is coming from this. So from the sight glass you can see the return line, whether the oil is returning the circulation or not, because there is no tank to measure in this case. Okay, because there is no tank to measure, you need to see the return line, whether oil is returning back or not. Okay, that is why sight glass is provided. If the tank is there, you won't find a sight glass, because a tank will have a level gauge to show you that the oil is returning back. In this case it is through a sump tank, so a sight glass is provided. So from this line, similar to this one, you have 2 filters, and then you have 2 pumps. One is on standby, one is running, and then from there must be a pressure switch. Once the pressure falls, the other pump will run. So one pump fails, other pump starts, or pumps reduces pressure. So this is how the system is there. So it is shown that it is 1.5 to 2.5 meter from the center line. So your oil return line here, you can see return line, maximum height is given. So height is given as 1.5 to 2.5. So you can calculate the pressure from here. 1.5 is 0.15 bar. So 0.15 to 0.25. This is the pressure over here, a little bit more because pump is there. So pump will pressurize, but seal side pressure, I mean the stern tube side pressure is always higher. Okay, the seal pressure, the pressure of oil inside this will always be lower. Okay, it will be in the range of 0.2 to 0.4 bar, and here the pressure will be higher. So and then there are drains also. Every sealing tank has you have a drain over here. You have a drain fitted over here for 3x3s. You have a drain fitted over here for 2x3, and then you have a drain fitted over here for the stern tube wall system also. So all these 4 tanks have drains over here. Okay, so this is about the explanation from this diagram. Okay, when we meet next, we will discuss something more in details about how this flow controller is working and how the amount of air is maintained the draft as per the draft changes. Okay, thank you.